This call is now being recorded. This call is now being transcribed. This call is now taking notes.
All right, there's a MEL for that. Up, up, and away. Aviators, avionics. And we'll begin. Now, come on, call messages up. All right. What are the primary flight controls? What are the primary flight controls? Right, correct. The primary flight controls are the rudder, the elevator, the ailerons, and the multifunction spoilerons. Primary flight controls are the rudder, elevator, ailerons, and multifunction spoilerons. All right, this powers the brakes, moves the flight controls, and the landing gear. What system powers the brakes, moves the flight controls, and the landing gear? Very good. That would be the hydraulic system. The hydraulic system powers the brakes, moves the flight controls, and the landing gear. Oh. What is the max takeoff weight of a CRJ 700? And again, this is going to be structural. What is the max structural takeoff weight of a CRJ 700? Very good, 75,000 pounds. And of course, as has been mentioned in class, and I believe you guys talked about quite a bit with Allison last night, there are a myriad of factors that can reduce that max takeoff weight. But given perfect conditions, the max that a CRJ 700 can carry is 75,000 pounds. This document specifies which equipment can be inoperative on an aircraft and still operate safely. All right, I'm seeing a lot of people put MEL in chat. And what does MEL stand for? Very good. That would be the minimum equipment list. The minimum equipment list specifies what equipment can be inoperative on the aircraft and still operate safely. What are the primary functions of the APU? What are the primary functions of the auxiliary power unit, APU? All right, I'm seeing some similar but different answers in chat. Remember, we are talking about the primary functions. Primary functions are bleed air for engine start and to back up the IDGs. Our primary functions of the APU is to provide bleed air for engine start and to back up the IDGs. What do V1, V2, and VR represent? Very good. V1 is our takeoff decision speed. V2 is the takeoff safety speed. And VR is the takeoff rotation speed. All right, who can explain takeoff decision speed? Arian.
I believe that when you reach to V1, that's when you decide whether you will abort or you will go further to V2 and take off.
Yes, yep. V1 is the fastest that you can be going and still safely abort the takeoff. So that's our decision speed. That is the fastest you can go and still decide to reject the takeoff. After V1, we're committed to the takeoff. How about V2? Who can explain V2? I can't hear Pete if he's talking.
Oh, sorry. No, I wasn't. Yeah. V2 is the speed that ensures safe climb out if you lose an engine.
Yeah. So yeah, if so, at V2, if you were to lose an engine, you could meet all all right, and VR. Am I still frozen? I guess not. Nichelle says yes. VR is the speed at which the pilot begins to lift the nose off for takeoff. Yeah. So at VR rotation speed, that is when the pilot will actually begin to lift the aircraft off the ground. All right. This control surface is located on the vertical stabilizer and controls yaw. All right. I'm seeing a lot of people put rudder in chat. That is correct. The rudder is located on the vertical stabilizer and controls yaw. All right, how many hydraulic pumps and how many hydraulic systems on the CRJ 700? Very good. 3 hydraulic systems, 2 pumps per system for a total of 6 pumps. We have 3 systems, 2 pumps per system for a total of 6 hydraulic pumps across the 3 hydraulic systems. What is the max landing weight of a CRJ 700? Max landing weight of the CRJ 700, very good, 67,000 pounds. 67,000 pounds is the max landing weight of the CRJ 700. With an AC pack, what would our general MEL restrictions be? What MEL restrictions would we likely see with an AC pack? Correct. With an AC pack MEL, we would have an altitude restriction. With one operable AC pack, what altitude would we likely be restricted to? Very good. Flight level 310. With a single operable pack, our flight level restriction would be 310. AC packs will carry an altitude restriction. All right, what parts of the CRJ 700 have anti-ice protection using bleed air from the engines? What parts of the CRJ 700 have anti-ice protection from bleed air from the engines? That would be the engine cowls and the leading edges of the wings. The leading edges of the wings and the engine cowls have anti-ice protection from bleed air. That is why any restriction to the bleed air system will very likely also contain a restriction to flying in icing conditions, because we use bleed air to provide anti-ice protection. What restriction will we generally see with the anti-skid system? If there is a maintenance issue with the anti-skid system, what restriction would we likely see? Yeah, very good. Would not be able to take off or land from a contaminated runway if we had an MEL for the anti-skid system. No landing or taking off from a contaminated runway. This control surface is located on the horizontal stabilizer and controls pitch. Very good. The elevator is located on the horizontal stabilizer and controls pitch. And the elevator is located on the horizontal stabilizer and controls pitch. What are the three sources of AC electrical power on the CRJ 700? Correct. The IDGs, the ADG, and the APU are the three sources of AC electrical power. The integrated drive generators, the air-driven generator, and the auxiliary power unit. Those are the three sources of AC electrical power. What factor determines the landing category of an aircraft? What factor determines the landing category of an aircraft? All right, I see a couple people put in chat and said speed. Can you be a little bit more specific? Which speed? Speed at what point? Very good. Approach speed for landing. Aircraft's approach speed determines its landing category. What's interesting about the aircraft I deal with at Endeavor, we have some CRJ 700s, but our fleet is primarily CRJ 900s. The CRJ 700 is a Category C aircraft, whereas the CRJ 900 is actually a Category D aircraft. It likes to go fast. So we have to be careful when we are doing like tail swaps to make sure not only do we have to be aware because this 900 has more seats, but with that, with the 900 being a Category D aircraft, we have to make sure that we're not swapping it to a destination where we are not authorized to land a Category D aircraft, such as like Key West. We also tend to really confuse Delta a lot because they're not used to Category D landing minimums. So when other regional carriers are able to land, we may not be able to because the landing minimums would be higher for the 900 since it is a Category D aircraft. But they're the ones who want the bigger seat configuration, so that's what we fly for. Yeah. Landing category is determined by, or aircraft category is determined by approach speed. All right, general MEL restrictions associated with the bleed air system. Already mentioned one of these on an earlier question, but what general MEL restrictions are associated with the bleed air system? Very good. There would be an altitude restriction, and then no flight into known or forecast icing. Again, with that bleed air system doing a lot for the pressurization of their aircraft, there's going to be an altitude restriction. And with the bleed air system being used for anti-ice protection, there would be a restriction for flight into known or forecast icing conditions. All right, we talked about what areas use bleed air. Now, what areas of the CRJ 700 have anti-ice protection using electrical power? What areas of the CRJ 700 have anti-ice protection using electrical power? All right, very good. Areas of the aircraft that have anti-ice protection with electrical power is going to be the windshields and the air data probes. Windshields, and well, this says the pitot-static ports. That's a little bit of an oversimplification, but that would also be acceptable as a correct answer. All right, what is the definition of a contaminated runway? What is the definition of a contaminated runway? How would I know if it was a contaminated runway? All right, very good. More than 25% of the runway surface covered and more than 1/8 of an inch of contaminant or any amount of ice. So if my FICON says that the runway is covered in 25% of 1/8 inch compacted snow, is that runway contaminated? No, that runway would not be contaminated because it must be more than 25% or more than 1/8 of an inch. All right, this control surface is located on the trailing edge of the wings and controls roll. Located on the trailing edge of the wings, this control surface controls your roll. And as you all put in chat, that would be the ailerons. The ailerons are located on the trailing edge of the wing and control roll. All right, what is the primary source of AC electrical power? Very good. The primary source of AC electrical power would be the integrated drive generators, the IDGs. These are the weights that make up payload. What weights make up payload? Very good. Passengers and cargo make up payload. Payload is passengers and cargo. All right, general MEL restriction associated with the weather radar. What MEL restriction would we see if there was an issue with the weather radar? Very good. No flights into known or forecast hazardous weather. No flights into known or forecast hazardous weather if there is an issue with the weather radar. Document specifies which non-structural external components can be missing on an aircraft and still operate safely. Document that specifies external parts can be missing on an aircraft and still operate safely. That is correct. That would be the CDL, the configuration deviation list. The configuration deviation list, the CDL, tells us what external components external components can be damaged or broken to operate safely. What is method one? Yes, method one drift down is taking off from a weight that if an engine failure were to occur anywhere from V1 to the destination, the aircraft will clear all obstacles by 1,000 feet within 5 statute miles of either side of intended route until reaching the destination. So we talked about V2 being the speed of our climb parameters. If we were to lose an engine between V1 and V2, that's when we would employ method one down. All right, these are located on the top portion of the wings, and they assist in roll control at lower speeds. Located on the top portion of the wings, they assist in roll control at lower speeds. Very good. This would be the multifunction spoilerons. The fun thing about engineers is that we're extremely creative. So when an engineer developed a control surface that could function as a spoiler and an aileron, they called it a spoileron. Our multi located on the top of the wing. They assist in roll control at low speeds and are only deployed on the onward traveling wing. They will also activate alongside the spoilers at landing. What is the emergency source of electrical power? The emergency source of electrical power. Very good. The air-driven generator is the emergency source of electrical power. If everything else has failed, the air-driven generator will deploy from the nose of the aircraft and provide emergency power. All right, our aircraft performance is based on one assumption. What is our aircraft performance calculations based on? That is correct. One engine operative. Our performance calculations are based on one engine inoperative. All right, general air restriction associated with the integrated drive generators. What general MER restrictions are associated with the integrated drive generator? That is correct. The APU must be constantly running, and along with that, there would be an altitude restriction. APU running in flight, and an associated altitude restriction. Sake. What stages of the engine do we draw bleed air from? What stage of the engine is bleed air drawn from? Correct, that would be 6 and 10. What is the primary stage? Very good. Our primary stage is stage 6. Sixth stage and 10th stage of the engine is where we draw bleed air from. Last question, explain method to drift down. Who can explain method to drift down? Very good. Method 2 drift down is take off at a weight that if an engine fails during cruise, the aircraft can descend to a simple alternate while being able to clear all obstacles by 2,000 feet within 5 statute miles of either side of the intended route of the alternate. So method 2 drift down, that would be assuming we made it to V2, allows us to go to a drift down alternate if we were to lose an engine to avoid the weight penalty of using method 1 drift down. Final Jeopardy! What is the emergency backup pump for the CRJ 700 hydraulic system? What is the emergency backup pump? That is the 3B pump. Very good. And what gives power to the 3B pump? Which of our electrical systems powers the 3B pump? The 3B pump is an emergency system. So where do we get emergency power? Very good. The ADG. Our emergency power to emergency hydraulics. The 3B pump is powered by the ADG. All right, the time is 18:33 Mountain Time. Let's go ahead and take a break. Let's 18:43. questions do you have from the quiz review? Or any material that will be on Monday's quiz? I did want to bring up one thing that was not covered in the quiz review. We did talk about the primary functions of the APU are for bleeder for engine start and as a backup source of electrical power. What are the secondary functions of the APU? Secondary functions of the APU. Yeah. AC electrical power on the ground, aircraft air conditioning, and then as a backup source of bleed air in flight. And then what is, if an aircraft has an inoperative APU, what do you need to ensure is available? If you're dispatching an aircraft with an APU, what do you need to ensure is available? Ground power. One, let's see the thing. Yeah, GPU and air start. We had a interesting time in Minneapolis today. For those of you who are not aware, we are currently experiencing extreme cold weather. It got down to negative 25 last night. It's going to get down to negative 23 tonight. And the station left all of the air starts outside. And air starts are giant diesel motors, and they all froze up. So I think there were 2 functioning air starts for the entire airport that everyone was trying to share. And we actually ended up having to cancel 2 flights because we had an aircraft with an inoperative APU. And after delaying the flight 3.5 hours, waiting for one of the 2 functional air starts to be brought over, the crew was at risk of timing out. So we just ended up canceling the flights. Then after that, magically, there was another air start available. It's almost like someone got the message at that point that they need to work. All right, if there are no other questions from the quiz review, we're going to do some legal to go. pull up the worksheet here real quick. We'll start with the legal to go worksheet. Already done the walkthrough. It's helpful since our lesson plan tonight says do 3, 4, and 5. Anyway,
How much experience do you guys have? Ooh. With one navigate, two navigate. Okay, let's do some derived alternate minimums. All right, when we are selecting an alternate airport, be it for our destination or a takeoff alternate, we need to make sure that we can legally land at that alternate. And in order to give us an increased margin of error, if we had to divert, we add additional minimums for planning purposes on top of the posted minimums for that approach for that airport. Because we don't want to plan a flight to an airport, have that airport below mins when we get there, unable to land, divert to another airport, and then not be able to land there either. So that's why we add alternate minimums on top of what the posted minimums are for the approaches. Now, that being said, once the crew makes the decision to divert, their landing minimums now become the published minimums, not the additional alternate minimums. But that's why we add the alternate minimums, so that we have that extra buffer. Now, there are two different methods that we can use for deriving alternate minimums. We can either use the one navaid rule or the two navaid rule. The one navaid rule assumes one functioning navigation facility to one runway. When we are using the one navaid rule, we will add 400 feet to the decision height and 1 statute mile to our visibility. Our other option is to use the two navaid rule. Using the two navaid rule, we can add 200 feet to our decision height and a half statute mile to the visibility, but we would need 2 separate navaids to 2 separate suitable runways. So for instance, if we were planning a flight to Denver and we wanted to use Colorado Springs as our alternate. By the way, if you're ever planning a flight to Denver, Colorado Springs makes a fantastic primary alternate, but never rely on it being available, because the second that flights start diverting from Denver, they're all going to Colorado Springs, and if you're not one of the first flights on the ground, you're not getting serviced. So have a backup plan. Wait, computer, why you do this? Well, as far as what would be other good alternates, that would really determine what is in your company's C70 list. The C70 list is the list of airports that your company is authorized to fly to. Well, we could go ahead and pull up handy dandy Sky Vector. Yeah, Trevor.
Would there be a NOTAM or something like that that would let us know that it's close to additional traffic at the moment, or is that something that we would find out last minute?
So rarely are they going to say the airport is closed, especially since last year, I think it was Huntsville. It was either Huntsville or Mobile. Got in a lot of hot water with the FAA because they published that the airport was closed because they didn't want additional diversions there when there was no like safety critical reason that the airport would be closed other than the fact that they didn't want anyone else diverting their planes there. So there might be a NOTAM published saying closed to diversions, but that's unlikely. That would just be something you would want to coordinate mainly. For instance, when I was at Breeze, we had a diversion tracker. We had an alternate tracker that would, anytime a dispatcher published a flight plan with an alternate, it would then put on the tracker like what the planned alternates were, and like if one single airport started to get overloaded, like if we had a bunch of flights going into Hartford and everyone was planning Providence as their alternate, it would start alerting them as like, hey, plan a second alternate because if we have 2 or 3 flights divert to Providence, they're not going to be able to handle anymore. We have a similar tool at Delta that alerts us not so much like how many flights have specific airports planned as their alternates, but it will alert dispatchers like how many flights have diverted to a specific airport and how many more aircraft that airport can handle. So if we look here is Denver, as my screen goes blank. 110. Where's my... that one. But generally speaking, for Denver, I don't know why SkyVector is having issues. I would be looking at like Scotts Bluff, Cheyenne, Laramie. If I had a smaller aircraft that they could handle, Pueblo, perhaps. But those would be my big ones. I love Scotts Bluff. They're a great airport to work with, at least in my experience. Cheyenne's good if it's not windy, but it's always windy in Cheyenne. Same with like Laramie and Casper, both good options if it's not windy. But again, this is eastern Wyoming we're talking about, and it's gonna be windy. That's just the reality of life there. North Platte isn't bad. But again, it really comes down to what airports your airline has on their C-70. As to what you can choose from. So for instance, when I was at Breeze, we started flying, or we announced that we were going to start flying to Denver. And so I put together a whole packet of what airports we needed to add to our C-70 list. That I thought would be good alternate options. And I evaluated, ARF capabilities, runway lengths, instrument approach availability, whether or not they had handling capability for the aircraft. I mean, to the point of calling the stations and saying, hey, this is the airplanes that we're looking at bringing to you guys. If we had to divert there, can you handle them? In fact, Scotts Bluff told us, yeah, a lot of them had never heard of an Airbus A220. But when I called Scotts Bluff and talked to them, they're like, "Oh yeah, Air Canada uses us as an alternate all the time. We handle A220s, pretty regularly." So put together this whole report, took it up to the VPs, presented it, said, "Hey, we should add, you know, Laramie, Casper, Scotts Bluff, North Platte, and um, Cheyenne to our C70 list to use as alternates for Denver." And I really didn't expect any pushback because when we started flying to California, suddenly airports all over California started popping up on our C70 list to use as alternates. Well, then a few days later, I get an email back that said, "Hey, thanks for your time. However, we already have Colorado Springs and Grand Junction on our C70 list, and we don't see the need to commit the resources to evaluating additional airports as alternate options for Denver." Well, here's the problem with that. Again, with Colorado Springs, if you're not one of the first flights on the ground, it's going to be really, really hard to get handling because everybody wants to divert to Colorado Springs as soon as Denver goes down. And with Grand Junction, to get there, you have to cross the mountains. Doesn't seem like a great diversion option to me. Having to cross the mountains to get there in the event of a diversion, because we're going to have to calculate method 2 drift down for our alternate burn, which is going to require a lot more fuel because now I'm going to need drift down alternates just to get to my diversion airport. I need alternates for my alternate. So wasn't too thrilled about that response, and I basically told them, I was like, if that's how you feel, just plan for us to be diverting a lot of planes to Wichita, because that's our next closest, what I would say, suitable airport, because Colorado Springs is not suitable and Grand Junction is not suitable. We'll actually look at Grand Junction tonight, and I'll show you additionally why Grand Junction is a terrible option as an alternate airport, even under ideal circumstances. So, again, here is Denver right here. Colorado Springs is right here. That's sharing. It's not sharing. Of course, it's not sharing. Why would it be sharing? But yeah. So as far as like what good alternate options would be, it really comes down to what you're authorized to fly to and then picking your best options from there. But let's go ahead and take a look at Colorado Springs, because on the whole, there's a reason that people want to divert there, because it is a good airport to divert to. All right, so when we are looking at what runways we can consider when planning alternate minimums, the first thing we need to pull up is going to be our 10.9 alpha page. And that's this page here in our charts. We know it's the 10.9 alpha because right here at the top of the chart, right below where it says Jeppesen, there's a little oval that says 10.9 alpha. And specifically what we want to be looking on our 10.9 alpha page is this block here. Let me zoom in a bit. Right here in the bottom right of the page where it says for filing as an alternate. Now, if I was just going out on my own, flying private or even flying commercially outside of Part 121, if I was planning Colorado Springs as my alternate, I would have to use the alternate minimums listed here on this chart. That's what I would use for my alternate minimums. However, since we are flying Part 121, we can do derived alternate minimums using the 1 nav8 or 2 nav8 rules, which will usually give us better than what's published here. But what I do have to check here is which approaches I can actually use when I am considering Colorado Springs as my alternate, because not every approach that is published in my chart packet can be used for planning as an alternate. So I have to double check here what approaches I can actually use. And I can see here I can use the ILS to 3.5 left, ILS to 1.7 left, authorized only when local weather is available. So if I didn't have a local METAR available, I could not use 1.7 left. ILS to runway 3.5 right. RNAV, don't care for this class. RNAV, don't care for this class. Localizer to 3.5 left. NDB to 3.5 left. Wow, Colorado Springs still has an NDB. That's impressive. Localizer 3.5 right. RNAV, don't care about. RNAV, don't care about. VOR to run 7 left. And then authorized again only when local weather is available. The localizer to 1.7 left. So those are the approaches I can plan if I were planning Colorado Springs as my alternate. And again, I don't care about any of those numbers because I can calculate my own alternate minimums that are going to be lower than that. But I do see, let's see, I have ILS 3.5 right, ILS 3.5 left, ILS 3.17 left. And the localizer for 1.7 left. So 1.7 left must not have an ILS, or it's not authorized. So that gives me a lot of options for planning Colorado Springs as an alternate. So if I wanted to use Colorado Springs for an alternate, I would need to find a suitable approach. And for that, we would need to look at what the relative winds were to make sure that we're planning the correct approach. So if we go ahead and pull up, let's just go ahead and do that then. Aviation weather. Well, let's just take a look here at 1-7 left. Maybe. If it wants to work. All right. Well, it is 1933 Mountain Time, 1934. Let's go ahead and take a 10-minute break, and we'll be back at 1944. All right, so let's go ahead and take a look here at 1-7 left. Oop. Let's go back to 1-7 left. If we look down here in our alternate block, we have all of, or in our landing minimums and block here down at the bottom, we have all of our relevant information that we need for deriving our landing minimums. And I can zoom in a little bit. I said a little bit. There we go. All right, assuming that we had the full ILS available, we can see here for a Category C aircraft that our decision height would be 200 feet and that our visibility is 1/2 statute mile. So given that information, I could plan Colorado Springs as an alternate using simply the 1 NavAid rule. Add 400 to my decision height, that would bring it up to 600, and add 1 statute mile to my visibility, which would bring it to 1.5 statute miles. Which is great unless the entire front range was socked in and I needed better than 1.5 and 600 feet. If that was the case, I could start looking at using the 2 NavAid rule. In which case, I could take 2 separate suitable approaches to 2 separate runways, and to the highest minimums of each approach, add 200 feet and 1/2 statute mile. So for instance, if I was planning, let's say the winds are coming from the south, so I want to plan 1-7 left and 1-7 right. So we know for 1-7 left, I have 200.5 that I can use. And then if I go to 1-7 right, which we don't have the chart for, that's helpful. All right, let's look at the 3-5s. Let's say the winds are coming from the north, so I'm planning the 3-5s. I want to plan the ILS to 3-5 left and the ILS to 3-5 right. So looking here at 3-5 left, once again, using the full ILS, I have 200-foot decision height and 1/2 statute mile visibility. And then if I look at the ILS for 3-5 right, the parallel runway, I have 200-foot decision height and then 3/4 statute mile visibility. So in order to apply the 2 NavAid rule, I would need to add 200 feet to the highest of the 2 decision heights. They're both a 200-foot decision height, so we can go ahead and make that 400 feet for my decision height, and then 1/2 statute mile to the highest of the 2 visibility. The ILS for, what was this, 1-5 left, or 3-5 left, sorry, gave me 1/2 statute mile visibility. And the ILS for 3-5 right gave me 3/4 statute mile visibility. So in that case, I would need to add my 1/2 statute mile to the 3/4, which would give me 1 1/4. So my alternate minimums for Colorado Springs would then be 400 feet and 1 1/4 statute miles. So by using the 2 navade rule rather than the 1 navade rule, I've now brought my decision height down by 200 feet, and I've brought my required visibility down by 1/4 statute mile. But that brings up another question. Can we do better? And we might be able to. If, for instance, I was able to plan the ILS for 1/7 left and the ILS for 3/5 right. As long as neither runway has greater than a 10-knot tailwind, we could plan approaches in opposite directions. In fact, if I needed to, let's say that 1/7 right, 3/5 left has a disabled aircraft on it and it's closed. How many runways are there at Colorado Springs? Sam says 3. Christopher says 3. Trevor says 6. Nichelle says 3. Alan says 6. So the correct answer is 6. We have 6 runways. We have 3 lengths of pavement, but there are 6 runways. If I look at my north-south runway on the left, I have 3/5 left and 1/7 right. Those are considered separate runways. If I look at the north-south runway on the right, I have 1/7 left, 3/5 right. Those are considered separate runways. At the diagonal runway, I have 1-3 and 3-1. Those are considered separate runways. So as long as they were both suitable and as long as they had separate navades, I could plan 1/7 left and 3/5 right. And again, to be suitable, we would need to make sure that neither runway would give us a greater than 10-knot tailwind for the opposite directions. And then to ensure that they have separate navades, I would want to look here in this box right there. That's giving me the information about the navade. In this case, I'm looking at the identifier and the frequency. The identifier for 1/7 left is ILPI, and the frequency is 109.1. And for 3/5 right, I have IAHI 109.1. As long as either the identifier or the frequency are different, I can consider those separate navades. So even though they have the same frequency, because they have different identifiers, IAHI as opposed to ILPI, I can consider those separate navades. But if I wanted better minimums, let's say that 3/5 left wasn't closed, I could look at the ILS for 1/7 left, which gives me 200.5, and the ILS for 3/5 left, which gives me 200.5. Add 200 to the lowest of the 2 decision heights, They're both the same at 200. That gives me 4. And add 1/2 to the lowest of the two visibilities. They're both 1/2, so that gives me 1. So now my alternate minimums for Colorado Springs become 1 statute mile visibility and 400 feet decision height, which is the lowest that you can get using a standard ILS. Is going to be 401. So using Navade, 1 Navade, we got 600, 1.5. Using 2 Navade, if we used both of the north-facing runways, we got 400, 1.25. And then if we used 1 north and 1 south runway, we got 401. One Navade, 2 Navade, again, is one of those things that it's just going to take a lot of time, a lot of practice going through and practicing deriving alternate minimums until you really get it down. In fact, I never really got a firm, like what I would say, understanding of 1 Navade, 2 Navade until one day I was kind of just left to do busy work because our dispatch trainer had to go into a meeting with the FAA, and so one of the duty managers at Breeze, who was a former dispatcher, who was at the time an instructor at Aircraft Dispatch Academy, came over to me and said, "All right, I want you to calculate the alternate minimums for every airport on our C70 list using both 1 Navade and 2 Navade using current weather and NOTAMs." And so I spent the day doing nothing but calculating alternate minimums, and by the end of the day, I finally understood what I was doing. But that being said, what questions do you have right now as far as driving alternate minimums using 1 Navade, 2 Navade? And we'll look at a few more of these tonight. And we'll continue to look at them going on throughout the class. All right. Well, I told you I would show you why Grand Junction makes a terrible alternate airport. So let's go ahead and I will show you why Grand Junction makes a terrible alternate airport. Maybe. Why aren't you sharing my screen? There we go. Okay. All right. So looking at Grand Junction, again, first thing we need to do is go to our 10.9 alpha page. And figure out what approaches we can use for planning as an alternate. Just go away. We're useless. And we can see that we have the ILS for 11, the localizer for 11, and the LDA for 2.9. We don't care about the RNAVs because we can't use them for this class. However, the ILS for runway 11, the localizer for runway 11, and the LDA for runway 29 are authorized only when the control tower is operating. Now, if I were to go and look up the operational hours for the control tower, I would know that it only operates during the day. So I can only use those as planning for an alternate for Grand Junction during the day. When we were flying to Denver, it was at night. So when they told me that Grand Junction was a reasonable alternate, they hadn't even looked at the alternate requirements for Grand Junction. I had one approach, and that was the RNAV RNP for runway 11, which at the time, we weren't even authorized to fly RNP procedures. Now, let's assume we are flying somewhere in the day, and we want to plan Grand Junction as our alternate. Let's All right. We want to plan Grand Junction as our alternate. So we have the ILS for runway 11, and then we have the LDA for runway 29 for 1 nav 2 nav. Now let's assume that we could, in theory, fly to runway 11. Winds don't usually favor it, but today, hey, the winds are favoring it. So let's take a look at what our minimums would be. And it's during the day, so the tower's open. So, looking at our full ILS for runway 11, I have a decision height of 200 feet and a visibility of 3/4 statute mile. Using one nav aid, so adding 401, I could get a visibility for my alternate minimums of 600 feet. Or, decision height of 600 feet and a visibility of 1 3/4. Now let's see if we can do better than that going to 2 nav aid. So for 2 nav aid, I have the ILS to runway 11 that I can plan, and I have the LDA to runway 29. Let's assume that I can use the opposite runways. There's no prohibitive tailwinds. So I can look at my landing minimums for runway 29. And here we see that I have a decision height of 600 feet. And for our CRJ 700, which is a landing category C aircraft, a required visibility of 1.5 statute miles. If I were to do 2 nav aid, I would need to add 200 feet to the higher of the 2 decision heights. So for 29, I have, let's see, this says 539. I'll round that up to 600. And for 11, I have 200. So the higher of the 2 would be 600. So I'll add 200 that. That now gives me a decision height of 800 feet. And then I'll need to add 1/2 statute mile to the higher of the 2 visibilities. For 29, I have 1.5. And for 11, I have 3/4. So I'll need to add that to the 1.5. So using 2 nav aid, that now gives me alternate minimums of 800 and 2. 800 feet, 2 statute miles. Whereas using 1 nav aid, I was able to get alternate minimums of 400 and 1 1/4. So rarely, but it will happen, and Grand Junction is one of those famous cases where it will happen. You can get better alternate minimums using 1 nav aid as opposed to 2. But all in all, Grand Junction is a terrible airport for an alternate unless you have no other options. As for the questions in chat, I don't recall bringing up what the fuel burn rate was. That may have been something that Caleb talked about on fuel burn rate. I know at Endeavor we plan on 260. For the APU fuel burn on the ground. But I would have to check on what we plan for this class. But I know it is 260. So let's go with 260 since that's what's in the Quizlets as well. If everybody's good with that answer. Tell you what, I'll double check on Jaden with that, and we'll have an answer posted in the classroom. It could be one of those things where there's just a disconnect in the information. A lot of the stuff used in this class was pulled from SkyWest back in like 2016, I think. And a lot of it's also derived from other information. So the course material may say 200. So we'll just double check on whether it is 200 or 260. Like I said, I know we always plan 260. And if I said 200, I do apologize. Unless 200 is right, and then I'm right and everyone else is wrong.
There could very well be a difference between its actual burn rate and your planning factors too. But 260 sounds safe.
I like 260. We always planned on 250 for the A220. And APUs are pretty generally about the same across the board, more or less speaking. As opposed to like the engines, which can vary massively from one aircraft to another. But we'll get an answer for you, and we'll have it in chat. And we'll have it in the classroom, I mean. Posted as whether or not it's 200 or 260. All right, questions on one navigate, two navigate. From what we've gone over thus far, we'll probably look at one more example before break. All right, keeping in the theme of airports that we could use as alternates for Denver, let's go ahead and take a look at Laramie. All right, so here we have the charts for Laramie. Now, Laramie does not actually have a 10.9 alpha page. We do have the information for filing as an alternate right here on the primary 10.9 page, right down here at the bottom right-hand corner. So I see for Laramie that we can plan the VOR DME for runway 12 or the VOR DME for runway 30. However, I could not use both 12 and 30 for a 2 nav aid rule planning for Laramie, because if I look at my nav box, I see that my identifier is LAR with a frequency of 117.6. And for runway 30, my identifier is LAR with the frequency 117.6. Thank you. So I could only plan one nav aid for Laramie because I only have one navigational facility for both runways. So I can look here and see that for runway 12, I get a decision height of 305 feet, which we will round to 400, and a visibility of 1. And then for runway 30, I have a decision height of 322 feet, which will round to 400. And assuming I have all of my functional equipment, a visibility of 3/4. So as long as the winds allow me to plan runway 30, I can use the minimums for runway 30. Adding my 400, that gives me 800, and adding my 1, that gives me 1 3/4. So if I wanted to plan Laramie as my alternate for Denver, that would give me alternate minimums of 800 and 1 3/4. If the winds favored runway 12, I would have, again, decision height of 400, add 400 to that, that's 800, visibility of 1, add 1 to that, that gives me 2 statute miles. So if I had to use runway 12 for my alternate planning, that would give me alternate minimums of 800 and 2 statute miles. Does everyone understand how for Colorado Springs we were able to plan opposite sides of the same runway using 2 nav aid? However, for Laramie, I cannot use opposite sides of the same runway for 2 nav aid. Perfect. Yeah, because with Colorado Springs, I had ILSs to both runways, which gave me separate identifiers, even though they were on the same frequency. For Laramie, planning the VOR approach, same identifier, same frequency. I do not have 2 separate nav aids. Now, one thing that I see often come up in person is students will say they can't plan a particular approach because it's not an ILS or a localizer. We can plan for this class any ground-based procedure as long as it is listed on the 10.9 or 10.9 alpha page as approved for filing as an alternate. So that means we can plan ILS, we can plan localizer, we can plan VOR approaches, we can plan NDB approaches. Any of those are on the table for us for planning for both our destination and our alternate. It just has to be a ground-based approach. The only ones we cannot plan would be RNAV approaches. Those ones are the ones we cannot plan. But we can plan ILS approaches, we can plan VOR approaches, we can plan localized approaches, and we can plan NDB approaches. Now, whenever possible, we want to plan the ILS approach because an ILS approach will always give you your lowest landing minimums. The ILS approach is always going to give you your lowest landing minimum. So as long as we can find an ILS, we want to try to plan it. However, here for Laramie, we see there isn't an ILS available. So we could not plan an ILS approach for Laramie just because we don't have one. This is also one of the other reasons that makes Laramie a little sketchy for alternate planning because they don't have an ILS approach, but that doesn't mean that it's not possible to be planned as an alternate. Kind of the same issues with planning like Provo for Salt Lake City because Provo doesn't have an ILS to the predominant runway just because of the way the approach procedure is and where the mountains are, which is the same issues that we saw in Grand Junction. Let's go ahead and knock out one more before break. Let's take a look at St. George. Actually, I don't like St. George. Let's take a look at Ontario. Let's say we're flying to LAX now, and we're gonna plan Ontario as our alternate. By the way, if you're ever real world planning flights to LAX, Ontario is a fantastic alternate because everyone is going to try to divert to Orange County, which leaves Ontario wide open for you to send your flights to. Ontario, Palm Springs, San Bernardino, all great options for that area. So again, if we're planning as an alternate, we need to double check what approach procedures we can use for planning as an alternate. And I see that I have the ILS for 2-6 left, the ILS for 2-6 right, the ILS for 8 left, the localizer for 8 left, the localizer for 2-6 right, the localizer for 2-6 left. So I can go through. With this being California, winds are going to usually favor the 2-6s. So we're just going to go ahead and assume that we're planning approaches to the 2-6s. Since this is a made-up scenario, not real-world dispatching. So I'm going to go ahead and look at the ILS for 2-6 left. Gives me 200.5 if I have the full ILS. And for the ILS for 2-6 right, gives me 200.5 if I have the full ILS. As long as nothing is NOTAMed out of service, I can plan the full ILS using 2 nav to both runways, both approaches. Adding 200 feet to my decision height gives me a decision height of 400 feet. And then adding 1/2 statute mile to my visibility gives me a visibility of 1 statute mile. So I can now get my lowest possible alternate minimums of 1 statute mile and 400 feet decision height. All right, after break, we're going to do a little bit more weight and balance. But before we go into break, what questions do you have on 1 nav aid, 2 nav aid, and alternate planning? Or deriving alternate minimums, I should say. And just like filing for your destination airport, obviously, any alternate that you're planning, you're also going to need to look at the NOTAMs for, as well as the weather for. Because if any of these runways are closed, or for instance, if the ILS was out of service and we had to go to the localizer, that's going to change what your alternate minimums look like. All right, in that case, the time is 20. Okay, sorry, Brian.
Yes. So just to make sure I'm understanding this right. So if we had, I guess this isn't a real world scenario. I was about to say if the LOC ones gave us better minimums, but you said ILS usually gives us the best minimums, correct?
That is correct. And we'll talk about that more when we get into navigation as to why. But basically, TLDR is an ILS is what's considered a precision approach. So it's going to give you better minimums, whereas a localizer is a non-precision approach. So it's going to give you higher minimums.
Gotcha. Okay. Thanks.
And we'll dig into that a lot deeper when we get into navigation, which is, let's see, we got 2 weeks of meteorology coming up, maybe at the end of week 4, but definitely in week 5. All right, time is 21:30. Let's take a 10-minute break and be back at 21:40. All right, welcome back. For the last part of class, we will do another example of weight and balance. I believe you guys did one last night. Yes, no, maybe so. Okay. So we will do another example tonight. All right, so we will do. Let's use example for flight plan 4, Oklahoma City to LAX. So the information I need mostly here is going to be just for my weight and balance calculation. Is going to be, I need to know my route, again, is Oklahoma City to LAX. I need to know my tail number. Which is going to be November 754 Sierra Kilo. I need to know how many passengers I have. I have 65 adults. And I have 2 kids. And those passengers have a whopping 109 bags. Must be a sports team. Then once I have that information, we can go ahead and go to Handy Dandy SkyVector. And we are going to go from Oklahoma City to Los Angeles. And that gives us a total distance of 131.5 nautical miles. And that's all the information we need off the bat to start doing our weight and balance calculations. So let's go ahead and pull up our weight and balance page. Yeah. Okay. Our weight and balance page. If it loads. Come on. I believe in you. Huzzah. Okay. So on our weight and balance page, again, we can fill out a lot of this basic information. Date, we'll just call it today's date. Not a pen. Right here. And this is flight plan 4. What's max takeoff weight, CRJ 700? Oy vey. Yeah, 75. All right, from Oklahoma City to LAX. Now we need to determine what our Minto is. So I'll just use this little piece right here as our scratch paper, and we can go through again how we estimate our fuel burn for weight and balance. All right. When we got our direct route from SkyVector, that gave us a number of 1,031.5 nautical miles. We'll go ahead and round that 1,032. Now, I know some of you in this class think it's absolute heresy when we round these numbers. I know because I was one of you. I couldn't believe how much rounding was done when we were planning this, because I had just got done doing like my flight training, and like I felt like everything had to be super precise when we were doing weight and balance and fuel calculations and everything else, you know, when I was being a pilot. And then I came over to dispatch and like, that's close enough. That's, you know, we'll just round that. And it's good enough. And then in the real world, I realized just how accurate that is. That, yeah, when we say that that's good enough, that really is actually good enough. You know, when we do these calculations, if you round or you don't round, you might get a difference of like in your fuel burn of like 10 pounds, which is a whole lot of nothing in real life, because you'll burn through 10 pounds of fuel in less than a minute. It's you'll burn through 10 pounds of fuel in seconds. Like it's nothing. So when me or Allison or any of the instructors say we're just going to round here, you don't have to. Okay, we're not going to make you round. We're just trying to make it easier on you, because close enough actually is close enough. The dates, as long as you are in the ballpark of the figures that they expect you to get, just want to see that you know how to do the calculations and you understand what you're doing. They don't care that you got the weight and balance down to the 10th of a pound, or you figured out your flight time to the nearest half minute. You're just making more work for yourself. Trust me. I made way too much work for myself when I went through this class. All right, so round that to 1,032 miles, because in the grand scheme of flying from Oklahoma to California, half a mile is not going to change anything. You're going to have a difference of over, probably ATC gives you vectors into the final approach course. So 1,032. Now, because we know we're not going to be flying from point A to point B, we're going to increase this by 10%. To do that, we multiply by 1.1. Someone has a calculator open, or can open a calculator on the phone and give me that number real quick. I can pull it up on my computer. There we go. Thank you. 1135. Okay. Okay. 1,135. And when we do flight plan 1 together, you will see just how good this estimate is. In fact, I still use this process for estimating flight times when I need to build a flight and it's not one that would fly regularly. Like if I need to do a repo flight or a ferry flight between two cities that we don't regularly fly, I still use this process because it is just that accurate. I know it seems oversimplified, but it works. It just does. All right, so with our increase by 10% to allow for routing and allow for our SIDS and stars, that gives us a distance of 1,135 nautical miles. Now we're going to figure out how long it's going to take us to fly that, and we're going to divide by the average speed of our CRJ 700 of 400 knots, which gives us all right, so that gives us, let's call that 2.8. So 2.8 hours. What am I trying to say? This works for us now because we're trying to figure out pounds per hour. If I needed, like later on, when I need to know hours in minutes, what I can do to figure out minutes is take off the 2 and multiply 0.8 by 60. which would be 48 minutes. So this would be 2 hours and 48 minutes. But because my fuel burn is in pounds per hour, having the decimal figure for hours here actually works for me. Now, who remembers how many pounds we estimate for the first hour of flight? Yeah, 4,000. First hour is 4,000 pounds. So we'll go over here and say 4,000. That's our first hour. Which leaves us, if we take an hour off of here, 1.8 hours. Now, for each additional hour, we burn how much? 3,000. So we can multiply that by 3,000. Which gives us 5,400 pounds. So, adding our 5,400 to our initial hour of 4,000, that gives us our en route fuel burn of 9,400 pounds. What questions do you have on the math? Kiri.
Yeah, it's Kyrie, but
Sorry, my
no
apologies.
problem, no problem. I think I missed. Where did you get the 400 to divide the 135?
That is the average speed
Gotcha.
en route.
Okay.
Yep. That is what we assume our average speed is 400 knots. All right, for Minto, what else do we need to add to our fuel burn? Yep, alternate and reserve. We're not going to plan for an alternate tonight. We're just going to assume the weather in LAX is good enough. We don't need an alternate. Though if we did, we would use that same formula here to figure out our alternate burn. We would figure out the distance from LA to our alternate if we just said like Ontario, for instance. Figure out how long it would take to fly that. Multiply that by 3,000. Since we're already in flight, we don't have to climb. And that would give us our burn. You know what? Let's go ahead and do that. Let's go ahead. We have an alternate tonight. We have an alternate of Ontario. So I'll just pull it up real quick, like, just to save the time. Yeah, let's go slow, whatever. All right, so that is 41 nautical miles. So a whole lot of nothing. So again, if we wanted to figure that out, we have 41 nautical miles. And this is just going to be direct. We're not going to plan on SIDS and stars or anything else or routing. Because if we had to divert, we would be requesting direct to our alternate. So we're just going to go with that 41 nautical miles. Divide that by 400. That gives us 0.1 hours. Multiply that by 3,000. Gives us an alternate burn of 308 pounds. So we have an alternate burn of 308 pounds to get from LA to Ontario. And lastly, we need our reserve. How much reserve fuel do we plan for this class? "45 minutes," which is how many pounds of fuel? And 45 minutes isn't just for this class. That is the FAR. But specifically for this class, for our reserve fuel, we say that 45 minutes is 2,500 pounds. And as soon as I can pull up my form again, I will add that. Hopefully soon. So burn alternate reserve, that is what makes up our Minto. Don't tell me there's a problem. Just thank you. Just work. There we go. We can actually throw these numbers in with a video weight over here. There we go. I'm not going to plan hold fuel. So that will give us a Minto of 9,007. Oh, forgot my alternate fuel. Time to file an ASAP report. Or my reserve fuel. Time to file an ASAP report. Okay, so that would be 9. I'm not moving from mental math tonight. So that gives us a Minto of 12,208. So we can go ahead and put in here 12,208 for Minto. And for our alternate, we planned Ontario. No second alternate, no takeoff alternate. Captain signature, FO signature, and tail number. Last thing we need was 754 Sierra Kilo. All right. So that fills out our block information up there. Now we can start filling in our weight data. Again, going back to our scenario, we said we had 65 adults. And figuring out how much they weigh, we will go to our average passenger weight. And are we using winter weights or summer weights right now? Yeah, we'll use winter weights. So for 65 adults, gives us oh, 12,675 pounds. Then for children, we had 2 children. And we code X here for child weight. Again, we're going to be using our winter weight of 87 per child, which gives us, wow, that's not an equal sign. 174 pounds. And then we can find our totals for a total of 67 passengers, almost a full plane. And one, 2, 6, 7, 5 plus 174. Total passenger weight of 12,849, which we'll bring down to our second line here. Now, our first knot line was our basic operating weight for the aircraft. For that, we will find that in our information package. I'll just go ahead and pull that for now, since we are running out of time in class. From our CRJ 700 performance charts. And I see that aircraft 754 Sierra Kilo has a basic operating weight of 44,843 pounds and an index of 71.6. Next, I need to find our passenger index. To find that, we go to our back page on the chart here. Again, we had 65 adults and 2 children for a total of 627. Now, I believe Allison probably talked about this last night. For this class, we are always going to plan loading back to front. Obviously, that's not realistic in the real world, but that gives us our best performance numbers in the CRJ because the CRJ is very nose heavy. So we're going to plan for this class loading back to front. When you go to your practical, your DATE is going to tell you how many passengers are in each zone. That may throw you out of weight and balance. If that happens, you would want to bring that to the attention of your DATE and say, hey, with the zone counts you gave me, that makes our aircraft either nose heavy or tail heavy. It'll be nose heavy. I can't legally operate with those zone counts. Now, real world scenario, you might be adding ballast to the aircraft, especially if it would meant moving first class passengers. But for this class, we're just going to move passengers around. So the DATE would ask you, okay, how would you resolve that? And you would say, I would need to move some passengers from the front part of the plane to the back part of the plane in order to get back in balance. Go ahead and do that, adjust it, get back in balance, and call it a day. But for planning this flight, we're just going to start from the back and move to the front since we know that's going to work for us. And again, for this, we'll pull that off of our performance charts. And I'll just go ahead and fill these in for now. For zone F, we can have 10 passengers, so we're going to put 10 passengers in there. For zone E, we can have 12. So let's fill up zone E. For zone D, we can have 12. For zone C, we can have 12. For zone B, we can have 12. That gives us right now a total of 54 passengers. Yeah, total of 54 passengers. Why is my math not mathing? $58 passengers. That's how math works. We have a total of 58 passengers, which means we need 9 more in zone A. And then going off my table, 10 passengers in, or 9 passengers in zone A gives me an index of negative 14.4. Zone B gives me an index of negative 13.9. 12 in zone C is negative 8.5. 12 in zone D is negative 3.1. 12 in zone E gives me 2.8. And 10 in zone F gives me 6.8. I'll add up both of these columns. So that is 11.6. And then $14.4, 13.9, 8.5, and 3.1 gives me negative 39.9. I'll move my positive 11.6 here. Find the total of negative 28.3. And I'll go ahead and take that, negative 28.3, and plug it into my right-hand box here, since it's negative. Negative 28.3. Next, we're going to do cargo. Again, CRJ 700 is nose heavy, so we want to load all of our cargo in the aft cargo compartment when possible, even though that puts our planes at risk of rampers putting belt loaders through our engine cowls. Not that I'm speaking from experience. We have 109 bags. We'll use our average bag weights. We'll assume there are no specials. Which gives us a weight of 3,270 pounds. Which falls within our max weight of 3,740 pounds. So that means we can put that all in the aft. And then for our index for our cargo, we have our aft cargo index table right here. And we'll go down to 3270, which is actually on our table. Thank you. Which gives us an index of positive 21.7. We don't have any forward cargo, and we're not going to plan on a jump seater. So that takes care of our payload. Remember, payload is passengers and cargo. We'll go ahead and add up all of these numbers. So for our negative side, we have negative 28.3, and for our positive side, that's going to give us a positive 93.3. Bring this down here and find all of our totals. So first, I'll add up all of our weights. We have our basic operating weight of 44,840. Our pass weight of 12,849. And then our cargo weight of 3,270, which gives us a basic or a zero fuel weight of 6,000 or 60,960 pounds. And then we'll need our zero fuel index. So we'll do 93.3 minus 28.3 to give us a zero fuel index of an even 65. Next, we need to add our ramp fuel, or our takeoff fuel, our Minto, which is ramp fuel minus taxi fuel. Since we never calculated our taxi fuel, we're just going to go ahead and take our Minto, since that number is already nicely calculated for us, of 12,208. And then we need to find our fuel index. I don't have a 12,208 on here. I have a 12,000 and I have a 12,500. In this case, I'm just going to round to the nearest. So we'll go ahead and go with 12,000. Which gives me a fuel index of negative 1.3. Go ahead and bring that down. So for our takeoff weight, I'm going to add our zero fuel weight plus our fuel. Gives me 73,170 pounds. What's our max takeoff weight? Max takeoff weight for this CRJ 700 is... Anyone? You told me earlier. I know you know this.
We're blowing you up in chat. 75K.
All right, perfect. Oh, my chat wasn't reloading. There we go. Yep, 75,000. So we are under our max takeoff weight, and let's just hope it's not hot or humid in Oklahoma City. All right, last thing we need to calculate is going to be our landing weight. So to do that, we will take our takeoff weight, and we are going to subtract our burn. If you remember, our burn was at 9,400 pounds. We are not going to plan on using our alternate fuel, and we are not going to plan on using our reserve fuel. We're just going to assume we're only using our burn. We're only flying from Oklahoma City to Los Angeles and landing safely there. So subtracting our burn, that gives us 63770 for our landing weight. Oh, forgot to calculate our index here. So 65 minus 1.3 is 62.7. Sorry, 63.7. For our index, you have a couple ways you can do that. You can either calculate the index for the remaining fuel on the aircraft and adjust from your takeoff weight, or you can calculate the index for the remaining fuel on the, or you can calculate the index for the remaining fuel on the aircraft and go from your zero fuel weight index, or you can calculate the index of the fuel you burned and adjust from your takeoff weight. In this case, let's go ahead and do fuel burned method. So we planned on burning 9,400 pounds, so we can call that 9,500 pounds. And actually, I don't like that method. Let's do fuel remaining. So we burned 9,400. We have our reserve and our alternate remaining. So we will be landing with 2,808 pounds of fuel. So we find 2,808. Don't have a good number for that, but we do have 3,000, which gives us an index of negative 1.8, which we will take from our original zero fuel weight index. That gives us a landing index of 63.2. And that gives us all our numbers. And they all fall nicely within our limitations. Because what is our max landing weight? 67,000 pounds. Very good. So our 63,770 is under max landing weight. So we came in below max takeoff weight. We came in below max landing weight. So all of our weights check out. Our weight and balance is good. Last thing to do would be to plot all of those numbers on the little graph at the bottom to make sure they fall within the envelope. and we have done our weight and balance. And again, we will do this for, I believe 5 of the flight plans. We expect you to do your full flight plans, and the remainder we just expect you to do legal to go. So you will get more practice doing this. Week 5, we'll go through it again. Week 6, we'll start with flight plans 1 and 2. Flight plan 3, you guys will do on your own. Flight plan 4, we'll do together in class again, just to give you guys a refresher course on how to do everything. And then the rest of the flight plans you will do on your own. Questions on weight and balance calculations before we end class? All right. If there are no questions, we'll call class there. I'll be on for a while if you guys do have any other questions you want to ask. Other than that, have a good night, and I'll see you next week.
Thanks, Ryan. Stay warm.
I'll do my best.
Hey Ryan, I had a quick question for you.
Yeah, what's your question?
So I know since you used to work as a duty supervisor at Breeze, I applied several weeks ago. I was just wondering if you had any insight on their hiring process, just because in their timeline, because I got a knowledge test from them almost 2 weeks ago at this point, and I took it, thought I got it all right and did good, but I haven't heard anything since. So I don't know if that was normal or not.
Yeah, with Breeze, they tend to only hire pretty small classes, so a couple candidates at a time. And they get quite a few applicants, so even after the knowledge test, it does take them a little bit to winnow down who they're going to give interviews to.
Yeah.
Did you let them know that you were going through this course?
Yeah, I believe it was like an option of like, do you have your license? And it was like yes, no, and in progress. Then I
All right.
also
But
told
did you
that-
specifically let them know that you were at ADA?
Yeah, in my cover letter at least, that was like
Okay.
one place to put it.
So okay, hopefully they'll read that because I believe it's still a guaranteed interview at Breeze for Aircraft Dispatch Academy students.
Okay, sweet. I'll just
So hopefully you'll get that call back.
thank you.
For an interview. But like I said, they usually have a significant, like the number of candidates they get versus the number of slots they're hiring tends to be a pretty big difference. Um, just because they usually only hire, like, the biggest class I've seen has been like 5 dispatchers.
Right.
So I don't know. I'm assuming they probably lost some to the last round of United and Delta hiring, but I'm not sure like how big their class size was.
Okay. Sounds good. I'll just keep being patient. Hope I get something.
Yep. Good luck. Yeah, hopefully you do. I really enjoyed working at Breeze, especially as a dispatcher.
Yeah.
So
Yeah, I've been doing some job shadowing. I have another session with job shadowing on Thursday, so it's been really be nice to work there since I've already seen the flow of things.
gotcha. Well, if you run into Garrett, just ask him,
Okay. Sweet. Sounds good.
and then you'll. I mean, even if you don't get hired in this round, like, definitely talk to Garrett when he's down there in person.
Like in
Because he's. What was that?
like in St. George or when I go in shadow.
In St. George, and when you go in Shadow, because Garrett, he's the manager of dispatch at Breeze, but he's also one of the DAIDs
Okay.
for the school. So he goes down there and he does tests, and like when that's like his kind of like first impression of people that he wants to hire.
Okay. Sounds good.
Which is how I got hired. Him and Brian Button, who doesn't work there anymore. They were both instructors at Aircraft Dispatch Academy, and they were like, "Come work at Breeze. Don't go to regional. Come work at Breeze." I was like, "Okay, I'll
If you
give you
insist.
guys a shot."
Yeah. Good. Sounds good. Thank you.
Yep. Good luck.
Yep. We'll see you later.
Later.
I had a question too, Ryan. I know sometimes or I've been in a situation where I'm trying to non-rev for a flight, and
Mhm.
I noticed the gate agents, they're trying to figure out weight and balance, and to see if they need to check any carry-ons or bump someone to the next flight or something like that. Are they filling out this weight and balance form, or are they doing something totally different?
No, they would be working with, at that point, they're not doing the weight and balance. They're going to be working with either, depending on the airline, either a load planner or the dispatcher
Mm,
to figure out their weight and balance numbers. They're not the ones
okay,
doing the actual calculations.
got it. And then
Um,
with specials too, we were talking about like skis and things like that. I just thought of this at the last minute. Human remains, those are considered special items too?
oh, yeah. Yep.
Okay,
Anything that is a non-standard bag.
got it.
Yep. Sports equipment. Yeah. Human remains, that would be one. I was on a flight recently that had a deceased serviceman that was being transported to the National Cemetery
Is there
in the cargo hold.
a limit to how many they can put in the cargo hold?
I do not know. Because yeah, I do not know. I never been something I've experienced. So
Okay.
apologize. I do not have a good answer for you for that.
That's okay. Well, have a good night, whoever's still on here, and if you're in the storm's path, stay safe and warm.
Yeah, absolutely. And don't try to fly this weekend.
I was gonna go to Miami, but I
Where are
decided
you?
to stay here. I'm in Atlanta.
Okay. Yeah. Don't try to fly tomorrow night or Sunday morning.
Yeah,
Delta is canceling like everything.
yeah. My boyfriend, he
We
already told me, so
canceled.
that's why we decided to
Yeah.
stay.
I mean, if you left tomorrow morning, you might get out, but after like 3 o'clock tomorrow, I think they're pretty much trying to cancel off everything.
Yeah, even
Um,
my ADX got canceled because of the weather.
Oh, geez. That stinks.
Yeah, and it was for Monday too, but I guess they're closing that day just to be on the safe side.
Probably.
Yeah.
Yeah, I know our cancel package for Atlanta was like 107 flights
Mm.
between Saturday and Sunday. And then like JFK and LaGuardia, they're like, yeah, we're not gonna fly anything Saturday night, all day Sunday, and Monday morning.
Wow.
Yeah. So we like Delta is completely gutting New York. I'm just hoping I can get home Sunday
Yeah.
because I don't want to be cold anymore. I want a couple days where it's 40, not negative 40.
Yeah, I don't know how you do that, but more power to you.
All right. Well, have a good night. Stay safe.
You too.
Hi, Ryan. Just a quick question.
Yeah.
On your weight and balance, I see also a second alternative airport to be listed. Is it always
Yeah.
always required, or you don't do always? Oh, but when is it required? The second alternative.
So that is going to be a policy that is established by your airline of when you
Right.
require a second alternate. It will be when your destination and your first alternate are considered to be marginal. Now,
Okay.
marginal is not a term that the FAA defines. Marginal will be defined by your airline. So
Correct.
whatever their parameters for marginal are, if your destination and your first alternate are marginal, then you need a second alternate.
But when you do your destination, if your destination is marginal, would you not pick something alternate that's not marginal as your first alternate so that you don't have to choose a second alternate? Or is it because it's very difficult to choose when it comes to the weather, because of, all the vicinity may be affected due to the weather?
It could be something like that. It could be something where like, you're saying, this is my primary. I would prefer to divert here if possible, but their weather isn't looking fantastic either, but it may improve by the time we get there. But in case it doesn't, I'm also going to put this other alternate. Or it may be a situation where the TAF doesn't seem to be matching like what their actual weather is. And so you're going to go ahead and plan a marginal primary alternate because you have reasonable, a reasonable idea that their weather will be will be a possibility for you to go to when you get up there. Or it could be a situation like I was describing earlier where I'm flying to Norfolk. And if I have to divert, I would like to divert to Richmond, but I know that there are several other flights that are going to Norfolk that have Richmond as their alternate. So I'm going to plan Richmond as my primary alternate. But in the event that, Richmond is overloaded with diversions, I want a secondary alternate that I can go to in case I can't go to Richmond.
Oh, perfect. Okay. Cleared that out. Thank you so much.
Yeah. So your second alternate's generally like, I want to go to this airport. This would be the best option for me to divert to, but there is, there's a chance that I won't be able to get to my first alternate either because the weather won't be legal or I suspect that they're going to get overloaded with other diversions.
Got it. So that means that your second alternate possibly could be your most distant one.
Yes.
Got it. Okay.
Yeah. So that's why when they say burn to your most distant alternate, if you have more than one alternate planned, you're gonna calculate your burn to whichever one is the furthest away.
Got it. Okay. Yeah. Thank you so much.
No problem.
Have a good night, sir.
You too.